Moving on to the second problem of work done. The properties of a closed system change following the relation between pressure and volume as PV equal to 3.0, where P is in bar and V is in meter cube. Calculate the work done when the pressure increases from 1.5 bar to 7.5 bar. Now if you again read it, you can clearly see that there is a relation given between pressure and volume. See, whenever there is a relation given, check whether they are mentioning about the units of the variables or the parameters given in this equation. Here it is given that PV equal to 3.0 is the equation, and the P which is represented in this equation is in bar and V is in meter cube. So we are given the equation PV equal to 3.0. Now, as I have told that when you are solving a problem in work done, you need to clearly identify between two scenarios. One thing, whether we can identify the process directly from the problem, that is whether we can understand it as a constant pressure, constant temperature or constant volume or adiabatic process. If we can identify, that's the best thing. Otherwise, we will be solving the problem by using W equal to integral PDV equation. Here, since I am given PV equal to 3.0, this is actually our PV equal to constant equation. When PV equal to constant, it implies an isothermal process where T1 is equal to T2. And an isothermal process, we normally represent it in a PV diagram like this. Okay, and if you read the question, it can be understood that the process takes place according to PV equal to 3.0, and we need to calculate the work done when the pressure increase from 1.5 bar to 7.5 bar. So we can clearly understand that the initial pressure P1 is equal to 1.5 bar and the final pressure P2 is equal to 7.5 bar. Therefore, one will be the lower pressure, which is the 1.5 bar case, and the process will happen until point 2, which will be the 7.5 bar. You can see that from 1.5 bar, the pressure is increasing to 7.5 bar where the volume is decreasing. Therefore, this is a compression process which is happening isothermally. This is a compression process that is happening isothermally. We need to identify process like this. Now, the pressure P1, it is given in 1.5 into 10 raised to 5 Newton per meter square. This can be taken as 7.5 into 10 raised to 5 Newton per meter square, and for an isothermal process, we have the equation W is equal to P1 V1 ln V2 by V1, or we can apply the equation W is equal to P1 V1 ln P1 by P2 in terms of pressure. We have two equations, either this one or this one, and if you look at this equation or the terms which are given in the problem, I think this equation will be better suited. So I'll be taking this equation W is equal to P1 V1 ln P1 by P2. I know P1 and P2 and my only problem is V1. That is where, if you look at the question carefully, we are given PV equal to 3.0. What is the meaning of that? PV equal to P1 V1 equal to P2 V2, which is equal to 3. That is the meaning of an isothermal process. Therefore, this P1 V1 becomes 3. But the main thing is that in this equation, it is mentioned that the value of pressure is in bar and V is in meter cube. So I need to convert the bar into 10 raised to 5 Newton per meter square. So this will become P1 V1. I will substitute it with 3 into 10 raised to 5 so that I convert this bar into Newton per meter square. This into ln P1 by P2, say 1.5 into 10 raised to 5 divided by 7.5 into 10 raised to 5. So this will be my equation. You can see that this 10 raised to 5 and 10 raised to 5 will get cancelled. So if there is a ratio in terms of bar, I could have directly given 1.5 and 7.5. But you have to be very clear that this is a ratio. That is why this 10 raised to 5 is getting cancelled. Now when you do this value, that is when you do ln 1.5 by 7.5, you will be getting a minus value which is 1.609. This will be minus value that have to be included, and you complete the value 3 into 10 raised to 5 into this minus 1.609. Okay, you will be getting the answer in terms of joules. This is very easy if you can identify the process. It's the most important thing, identifying the process. Then you can directly find out the work done. And the answer is going to be minus 4.83 into 10 raised to 5 joules. That is going to be the final answer. The negative sign will come and it has to be included because we are having a compression process. Compression means you have to give the work there.